not this one? It's not this one. Yeah. Okay, so good afternoon or good evening, I don't know. Sorry, everyone. My name is Julie Le Cardinal. I'm professor at CentraleSupélec in France. And it's really a pleasure for me to be here today for this brand conference that I really love. I think I was here in 2002 for the first time when I was just finishing my PhD. And I really love this conference, so really enjoy it. It's also my pleasure today to introduce our first keynote speaker, Miss Daniela Pigosso. And she will, Daniela, I'll give some introduction about her. So Daniela is born and raised in Brazil, where she took her engineering education and PhD. After a short period as a guest PhD student at TU Berlin, she started a postdoc at DTU in Copenhagen. Daniela has been at DTU for the past 11 years, and I've got a brand new news to say because next 1st June she will have a professor position at DTU. So congratulations, Daniela. Her main professional focus is on minimizing sustainability impacts before they happen by helping companies to design products, services, and systems for sustainability. She's the principal investigator of an ERC consolidator project called Reboundless, which deals with the prevention of rebound effect by design, and this will be the focus of her presentation today. Her speech may seem provocative, but it is very inspiring. So enjoy, and Daniela, I'll let you the floor.
I knew that might happen. So our ability to design has actually enabled humanity to survive over the past many years. Since back in the Stone Age, 2 million years ago, humans have been designing the world around us. Just take a second and look around you. Everything that you can see is actually designed. And if I ask you in this room, what is design, we'd probably have 600 different answers. Design is a highly interdisciplinary topic, and I actually want to go back to the first definition of design as a scientific field. And this first definition came from Herb Simon in the Science of the Artificial book, and this is what he wrote. Design are courses of action aimed at changing existing situations into preferred ones. In other words, design, it's all about turning the world a better place. And that's exactly what this community have been doing over the past many years. And I want to really quickly go through, together with you, of how has been the evolution of design over time. It always started with a very strong focus on the designed artifact, where we were trying to change the world around us to be able to survive, but also to thrive. Over time, we realized the need for a more systematic process of designing, so we would actually have a higher efficiency and effectiveness in the way we are reaching our designed artifacts. And in fact, this is, I guess, one of the key research focus of many of us in this room today. But over time, we also realized that it was extremely important to have a better definition of the problem that we are trying to solve as designers. And that's when the focus on the user starts to become extremely strong. That's where we start to develop new tools and approaches for user-oriented design. And if you look into the actual design process, today we are in a very high development in a number of different areas, all the way from a very strong backbone in design theory, methods, and tools, to also really strong focuses on human behavior and creativity, AI and data-driven design, and also industrial design and many other different areas. And we've also been designing for a number of different things. We've been designing for healthcare, we've been designing for manufacturing or additive manufacturing, we've been designing for excellence, and we've also been designing for sustainability. All of that has enabled us to design not only simple artifacts, as back then, but actually quite complex systems that brings together the integration between people, technology, and also products. So I really think that we've really come a long way. And we've really done a lot over the past many years to change the world around us and to make our lives easier and better. And over the past 15 years, as Julie just mentioned, I've been working on design for sustainability, trying to understand how we can deliver more value to people at the same time as having the minimum possible impact in our environment. And I'd like to share 3 main examples of where I see design for sustainability reaching excellence, the topic of the conference today. But before that, I'm not sure if you noticed the coincidence between all of those different topics. They are what we are all going to be discussing the next 4 days. Those are the key topics of the Design Conference 2024. Now, let's have a look at those 3 examples that I brought to you. Starting with the first one that shows the advancement we've had over the past many years on designing more efficient technologies. And we've been doing that across a number of different areas, but also in relation to lighting. In this graphic over here, you can see how much more efficient we've managed to use energy to produce lumens over time, from back in the 1700s up until today. This is a logarithmic scale. And what we can see if you look at the 2 very top bubbles in this graphic is that LED lights today are about 90% more efficient than the products they are substituting or the fluorescent tubes. It's an amazing development that design has enabled us to do when bringing up new technologies that can reduce resource consumption both from a material perspective but also from an energy consumption perspective. Moving forward, I want to share a second example with you. And this example is actually coming from a project that I had the pleasure to work with. It was a small startup called EcoXpac that came up to Carlsberg some years ago, asking how circular their products actually were, and looking mostly from a packaging point of view. So looking into the beer cans, looking into the glass bottles. And Carlsberg actually said, well, you know, we have a quite good closed system. We do take back most of our packaging after the use phase, and we do recycle them. If possible, we reuse the glass several times. So I would say that it's quite circular. But then the small company asked, okay, and what? They showed a picture of a lake that was full of beer bottles from Carlsberg. And that was branded waste. That was all of the products that didn't actually manage to come back into the traditional return system that we have extremely well developed in countries like Germany or Denmark. And Carlsberg thought they could be doing something about it, especially when looking into how long it takes for those different products to biodegrade if they are left into the environment. So if you look into an aluminum can, it takes about 250 years for it to biodegrade in the environment. If we look into a plastic bottle, 450 years. And if you look into a glass bottle, it actually takes 1,000,000 years. And what Carlsberg did was to take up the challenge and say, yes, let's then design the first biodegradable beer bottle in the world, made out of paper pulp. And by doing that, we would still want to take back those bottles as many times as possible to recycle the material. But if for any reason the bottle ended up in nature, it would be possible to biodegrade. And after this project, actually, we have many other big brands committed to the fiber bottles, such as Coca-Cola, L'Oreal, and Absolut as well. Now, if we go to the final example, this is Too Good To Go. It's a small Danish startup that has created a very interesting and effective system to minimize food waste. The problem here that they saw was that about 1/3 of all food in the world today is going to waste. And it varies a bit depending on the type of food that we are talking about. But you can see here that it can reach up to 50% of fruits and vegetables going to waste. The reasons for that, of course, changes in relation to whether it is a developing country or a developed country. If we look at developing countries, then most of it is coming from issues throughout the value chain and in the processing of the food. But if you look into developed countries like the ones that we are living, this is related to retail and consumption levels, especially because the food doesn't look as fresh or as good as one of us would actually be willing to buy. And what Too Good To Go did was to develop a new system that allows supermarkets or restaurants to sell surplus food at the end of the day at a very limited fee, enabling then this food to be consumed by people and minimizing the waste that would otherwise be created. So 3 good examples of initiatives that take some interesting insights from design for sustainability for trying to minimizing the overall impact that we are having in the world at the same time as providing value to our customers. Those examples, they are at different levels, all the way from technologies to products and systems. And this has also been the development that we see in design for sustainability over time, expanding the scope to have a higher impact. So, yes, we've come a long way. But the question really is that enough? All those advancements that we've been having in design science, but also in the design artifacts that we've been creating, are they enough to enabling us to have a better life or to make the world a better place, as Simon would have said? Let's have a look at the very same examples now from a different perspective. Starting with the energy efficient technologies. Yes, they are extremely efficient in the consumption of energy. Never before we had so efficient technologies and products as we do have today. But what happens is that technology also makes things cheaper. And by making things cheaper, we end up consuming much more of them. And because we are spending so little energy during the use phase of those products, we end up using them for longer. So instead of actually achieving this energy reduction that we expected to achieve due to better technology, we are behaving in a different way, and by doing that, altogether, we actually have a bigger impact than we had before. If you look in the UK, for instance, the amount of energy they use today for lighting is 6,000 times bigger than it was 100 years ago. Now, let's have a look at the second example, the green fiber bottle. It is renewable and biodegradable. Our role in the project was actually to do life cycle assessments to ensure that the impact of this product wouldn't be bigger than a glass bottle that we reuse several times, for instance, or an aluminum can that we recycle. And one of the things that we decided to do at the time we were doing that study was to understand how people would change their behavior if they knew that those bottles are both renewable and biodegradable. And what happened was that people tended to just dispose those bottles in nature. They thought, it's sustainable already. I don't need to go to the traditional return system. They don't need to be recycled. And then in the end of the day, we had more littering, which really didn't help in achieving the overall goal of Carlsberg, that was to have a lower environmental impact. Now, if we go to our final example with Too Good To Go, yes, it is an extremely innovative and necessary system. But what happens in many cases is that we are changing the responsibility of whom is creating the waste from the supermarkets or the restaurants to the consumer. Many times when you get a bag full of food from Too Good To Go, the expiry date is the day after, which leads consumers to actually dispose the food themselves instead of the restaurants. In fact, about 22% of all food that is acquired through systems like this one goes to waste anyways. But I would say there's a bigger problem than this one, and this is that there's no incentive to the organizations creating waste to actually minimize waste at the first time. They are now getting money for selling their surplus, which leads to very little motivation to actually minimizing and preventing food waste at a first instance. If we go back to the question that I asked you a few minutes ago, is that enough? My answer is a big no. The way we are designing today, it's not really enough to address the big societal problems that we are facing, no matter how good our intentions have been. Up until today, or recently, the most traditional way of measuring whether a given product or service or technology was sustainable from an environmental point of view was through life cycle assessment. This is a methodology that allows us to understand the impact across the entire life cycle, from raw material extraction and manufacturing to use and end of life. And it enables us to say if A is more sustainable than B, or where C would be placed in this continuum. It's a relative measure. And that's what we've been designing using the past many years. The problem is that up until that point, we didn't really have a way to say whether something is sustainable in absolute terms. And that's what we have today. In the same way that design science has evolved over time, sustainability science has also evolved. And today, we can say whether a given product, system, or technology is sustainable or not in absolute terms. And this is using the concept of the planetary boundaries. The planetary boundary is basically looking to the biophysical limits of Earth and defines three main zones for looking into human activities. The first zone, the one in which we would be within the sustainable area, is called the safe operating space. This is where we can carry out our activities on a day-to-day basis without having any irreversible impact in the Earth system and in the way that it operates. The second area is the risk zone. This is where we are still uncertain in relation to what might be the consequences of additional impacts, might compromise the overall resilience of Earth of absorbing those impacts. But we also have a third area, which is the high-risk zone, and this is where we reach the tipping points, or the points of no return. That's where a change in the biophysical elements of Earth will not be possible to revert, and this might lead to life in nature in different ways than the ones that we are used to just now, and that we've been used since the Stone Age, back then when we started to design. And science has also looked into what are the key boundaries in the Earth system today, and they managed to measure how far out or in we are in relation to the safe operating space. And this is how the picture looks like. We do have 9 planetary boundaries that are defined by Johan Hockström and his group of researchers. And here we can actually see that 6 out of the 9 planetary boundaries are already outside of the safe operating space, some of them even reaching the high risk zone. And it's obvious that the way we've been designing have been contributing to a high quality of life, but it has also contributed to a very high consumption and production, a changing behavior that has led to the surpassing of 6 out of the 9 planetary boundaries. So I would argue that the way we design today, it's not really enough to address the problems that we are facing. And this goes way beyond environmental sustainability only. It has also been happening in other areas that are key to design as well. If we look, for instance, in relation to when seatbelts started to be developed, we can actually see a change of behavior of people that felt that they would be safe with the use of the seatbelts, and then they start driving in irresponsible ways, faster, leading to more accidents than before. And the accidents were, of course, not only targeting the people that were wearing the seatbelts, but also pedestrians or cyclists and other people in the mobility systems. So the way we design is not really enough to address the challenges that we are facing. But what is happening? Why is that not enough? What are we not really taking into account when we design? And I would say that there are 2 main things. The first one is that we have a very limited understanding of what are the impacts that will occur when we introduce our designed artifacts in the real world. we have very limited understanding of how these new designs that we are putting forward are actually changing behavior in a very complex socio-technical system, and how this might, in the end of the day, offset the overall sustainability gains, and maybe worse than that, even leading to higher problems than the ones we were trying to fix at a first instance, but also potentially creating other problems that wouldn't be there should the design not be implemented there. So what is happening is that unintentionally, we are designing our own problems. If we look into sustainability specifically, about 40% of all potential sustainability gains are never achieved, and this is due to what we call rebound effects. Rebound effects are unintended consequences of design driven by behavior and systemic changes, so second-order effects or higher-order effects that end up undermining the overall potential sustainability gains that we actually had when we designed that given intervention. But what then? Now we know that the way we design is not enough. We understand that one of the limiting factors is our limited understanding of the influences of the things we are designing in socio-technical systems and how behavior change over time due to that, leading to an offset of the potential sustainability goals. But what can we do to address that? And what I argue for is a paradigm shift in the way we design today to allow for the prevention of those rebound effects or unintended consequences in general, and doing that by design. Many would doubt whether design is actually a strong leverage point for that, but I have no questions. The same way that we've been enabling life for so long is showing how important design is in actually influencing behavior and change the way we interface with products, systems, and technology. And how can we do that? What would be required for this changing paradigm? There are three main things here I'd like to highlight. The first one is having a very deep understanding of behavioral mechanisms, how behavior change when we introduce our designs in the real world, and doing that not only in a qualitative way, but also having powerful simulation models that actually allows us to understand and to anticipate in the very early design stages how big or how small those effects can be, so that we can take one step forward, find where are the key leverage points or the areas in the system where a small change can have a big impact. And for those areas then, find what would be the most appropriate design strategies to implement, so to prevent those unintended consequences or rebound effects from happening. And by doing that, not creating the problems that are bigger than the ones that we are trying to solve. And this is exactly what we are doing in Reboundless. Reboundless is a ERC project for which I am the principal investigator. And with a group of multidisciplinary and cross-disciplinary people, we are trying to understand how to prevent rebound effects from happening by design. I'm going to explain you in a little bit more detail how we are going about each one of those areas. But you are also going to see who are the people behind this. They come from many different knowledge areas, from psychology and neuroscience to social sciences and ecological economics, engineering and design, and how joining forces we are actually addressing this, I would say, extremely important problem. Starting with behavioral mechanisms, what we are doing is to expand the current state of the art, which is focused on mainstream economics. There are a number of mechanisms out there describing how people behave, but they all assume that we behave in an extremely rational way. And we know that's not the case in most of the time. So what we are doing is to expand that towards behavioral economics, to understand how we behave in a very irrational way, but at the same time in an extremely predictable way. And then this looking mostly at the individual level, but then going one level further and also looking into social practice, and at a societal level, how we change our practices due to access to new designed artifacts. Those behavioral mechanisms then become building blocks to the modeling and simulation, which we are doing on the basis of system dynamics. So we are modeling all of the feedback loops that are connected to those behavioral mechanisms, looking into not only triggers and drivers, but also into the cause and effect inside them to have a deep understanding of how they work and why they work. And all of them are small Lego pieces, if you will, that we can then combine to model systems that we might be designing. We do that by having a simulation backbone that brings three main elements: the overall designed intervention that we have at hand to start with, but also the key characteristics of the socio-technical systems. And in this project, we look into four main needs: housing, mobility, nutrition, and consumables. And then finally, also looking into household economics and how we take decisions in a day-to-day basis. And finally, putting them all together for case-specific simulation models that will allow us for quantification of the potential rebound effect and also the identification of the key leverage points. This will really bring us data and information that we can use in the early design stages to change our designs so that we don't first implement them in the real world, we observe the rebound effects and we try to mitigate. No, we do it beforehand, and by doing that, they will hopefully never occur. But well, knowing the leverage points and knowing the magnitude of the rebound effects is important, but it's not enough. The next step then becomes understanding what are the leverage points through a number of simulation scenarios so that we can test a number of different what-if hypotheses and get a quite good understanding of what might happen when we introduce that new product, service, or system in the socio-technical system. This will help us to identify the areas in the system where we should act and where we should change the design at a first instance. And by putting in what we call reboundless design strategies back in the simulation model, then we can see how effective they might be in actually preventing those rebound effects from happening, having a quite positive change there. So those are the three main building blocks of Reboundless. And when put together, what we are actually aiming for, and my vision, is to come forward with what I call the Reboundless design theory. It will be the theory that will change our paradigm in design and allow us to account for the unintended and unforeseen consequences so that we can actually design better products, services, and systems. So moving towards reboundless design, what I see as the next important milestones for getting there is, first of all, to enlarge our focus for the design of socio-technical systems with a deep understanding of how our decisions affect not only the physical product, but also the behavior of people that are having access to those products. By enlarging the way we do design process, by allowing for an early simulation of potential unintended consequences in the very early phases of design. Then moving from a user-oriented approach or a humanity-oriented approach, as some are arguing just now, to what I call a life-oriented approach that will enable us to keep Earth working with the biochemical systems that we see at play today, and also having a full understanding of socio-technical system behavior over time to be able to make better decisions when we design. And I really hope that the reboundless design theory will go way beyond sustainability only. And by doing that, it will allow us to come a little bit closer to what Herb Simon envisioned design to be, as a course of action aimed at changing existing situations into preferred ones. And when we do that, I truly hope that we will no longer be able only to survive or to thrive in Earth, but we actually be able to flourish. Thank you very much for your... Thank you for your attention, and also for Mario Storga for the invitation. It's actually the first time I've been to a design conference was exactly 10 years ago, and it's super cool to come back today and be able to have a keynote. So thank you.
And the good effect of your speech is that we are going to have plenty of questions. So time for questions. Yes, please.
Thank you very much for a really excellent and really nice presentation. There are so many questions, of course, and this is a very challenging topic. And I wonder, basically I have many questions, but I can select one. Sustainable design also means that you need to have a systemic perspective and understand also not just what's happening in the design itself and the closed life cycle, but how to bring in the whole systemic perspective. And I wonder, have you also considered to look into other systems that can actually affect, like economical systems and legislation, standardization, and those things? Are you also looking into that in your models?
Mm-hmm. Yeah, that's a really good question. Thanks for that, Sophie. I would say that many people see policy as the main way to actually address rebound effects. I would say that policy can indeed help. I don't know to what extent yet in relation to design, but we'll be able to say that over time as we have the simulation models running. But what I also know is that policy can also lead to rebound effects. There are a number of examples of extremely ineffective policies that has led to less than expected, or even a backfire where we have a higher impact than before. And we are actually just now working in collaboration with the Joint Research Center from the EU Commission, the JRC, in two main ways. The first one is that we are writing together with them a policy brief to highlight the importance of considering rebound effects in EU as a whole, but also in innovation policies specifically, which will allow our focus on design to be heard and seen. But we are also working together with them to incorporate the rebound effects into their consumption footprint database, where they actually measure what's the consumption footprint across different member states, but they do that without considering rebound effects just now. So I do believe that design together with policy, and of course understanding the overall dynamics of the economic systems and so forth, is really key to address that problem.
Thank you very much. Maybe I will have someone else.
Yeah, thank you. Jonathan? Yes.
My name is Ahmed Kovacevic. I'm from City University of London. Thank you very much for this very exciting talk. As I understand design, and maybe as we all understand design, it is a problem solving, and in a problem solving it requires some sort of a freedom, and that's why we go through cycles to actually explore all of these freedom things. By putting all of these three bounds on that, do you have any concern whether would it actually restrict, that freedom and generation of ideas that, in a very beginning, basically, of a design that could actually produce something which will even remove this rebound effect?
Yeah, thank you for your question. I think that this is definitely a risk, but I would say that usually the more constraints that you have in design, the more innovative you become in coming up with ideas that can solve those constraints. And I would say that this that we are proposing here is no different than a problem-solving approach. We are still trying to solve the problems that we see in the world, but the difference here is that we are not only looking into the first-order effects that happen when we implement or solve those problems, but we also look at the higher-order effects that we cannot fully understand without modeling and simulation. So the overall idea is to have more information, more knowledge, and more data that will allow us to have more effective designs that will indeed solve the problems and not only maybe postpone them or make them worse. So I truly believe that this might lead to actually more innovative ideas than we do have today on how to solve the biggest problems that we are facing.
Thank you. Yes.
John Giro is my name. I want to thank you firstly for a very clear presentation of what otherwise might have been a quite difficult set of ideas to comprehend. And I think in your last comment you introduced something I want to exercise you on, and that is you are showing that we want to move between first order effects into, let's call them, higher order effects. Donald Rumsfeld introduced a little statement about knowns and unknowns. We can design for knowns. He didn't use the word design, he was actually talking about killing people. He was the Secretary of Defense for the US. The word defense seems odd there, but anyway. He talked about knowns, which you can design for. There are known unknowns, and these are the second order effects. But there are also unknown unknowns. For example, the introduction of the internal combustion engine created an amazing effect which freed humans in many ways, but at the same time it killed very large numbers of them through exhaust pollution. And I wonder if in the early part of the 20th century that could have been predicted. So my question then is, how do we deal with perhaps higher order effects than the ones we already know about if we're introducing new ideas?
Yeah, it's a really good question. And I think that what we really need to try to do is, by linking second order effects into broader simulation models, we can actually come to things that we would never imagine that would be happening. When you have, let's say, 3 or 4 of those mechanisms taking place at the same time in a given socio-technical system over a given time horizon. By trying to look into what the effects would have been, we'd never have been able to build the model at a first instance. But by looking at that from a bottom-up perspective, trying to see what are the mechanisms that we know might be occurring due to current knowledge that we have of the systems, will potentially lead to this emergence of new effects that we would otherwise not know, and not be able to, at a first instance, come in with a guess that they might be happening. So our approach is really looking to what are the atoms, so to say, the smallest possible changes in behavior that might happen. And by doing that, enlarging our knowledge to things that we don't even know that might be there. But as we know, they are actually quite predictable in the way that they occur. So that's my goal and my hope and my vision. Yeah.
He's sitting next to me, so I'll take it, right? So first of all, I want to tell you that you actually killed my jet lag. So I was completely awake through your whole talk, and I really, really appreciated your talk. I just want to make a quick comment on this order effect. Strictly speaking, in mathematics, in Taylor series, the second order effects become important when the first order are 0. And that, I'm not joking, I'm serious, that you're assuming, or even John actually here, assumes that the first order, which was in this case transportation or whatever, is now 0. So we need to worry about the second order. But really, what you're talking about is not second order. It's actually 0th order. It's, thinking about solving, let's say, the transportation problem by thinking what happens to the entire planet. So my suggestion is, humbly, not to use the term second order, because if we take it literally, it means something else. Okay. And I still love your talk.
Yeah, I would love to have a conversation about you with that afterwards, because we are just now redefining rebound effects.
Yeah.
And I think it is a really important discussion to have.
Thank you, fantastic.
Thank you.
Last questions? Yes, here. Thank you.
Hey, also thanks from me for the interesting talk. I try to break down my question to a very simple one. With all the rebounds and loops and influences that can happen, are you confident that you can find a configuration that is like an optimum or that is better than now, so that you can change the things to a better thing? Mm-hmm. And maybe if you think that is true, can you give some example of maybe a real-world example of a television or something that you can modify in a way that it actually consumes less power?
Mm-hmm. Yeah, thank you for your question. I do think it is possible, especially if you consider the different leverage points that we can act upon in design. It goes all the way from very small changes, maybe in thickness or energy consumption, to changes in the way the system is operating, to changes in the mindset that is behind the overall systems. And I do think that design can be a very strong leverage in all of those different areas. There are already strategies out there that show potential, but I will only be able to say for sure that they can work once we have the simulation models running, because it might well be that we implement a given strategy, let's say nudge, where we try to change people's behavior, and we actually see that it leads to an even bigger problem than before, right? It's a never-ending story. So it's really important to put them back into the simulation models that are accounting for those different behavioral mechanisms to see what might happen. And if I take an example, so let's take the green fiber bottle, the example that I showed to you, that people actually decided to just dispose in nature because they thought it's more sustainable already. One potential way that could happen would be to give a higher deposit to that specific bottle, so an economic incentive that would actually provide people with the understanding that if it is more expensive, then I'll give it back. Could be a very simple example. We didn't test. I don't know whether that would work, but we are actually hiring now 2 new people in our group to look specifically into those design strategies so that we can go one level deeper. The project started a year ago, and we still have about 4 years to go.
Thank you very much. Very short one and last one. Thank you, Sirena. Yeah, thank you.
Thank you very much for your talk, very inspiring, and you share with us your passion, and I think that's really valuable, especially for the new generation of researchers. And my question is kind of practical one concerning the modeling phase, because you are combining together different subsystems that could evolve in different time frames. Mm-hmm. So I was wondering, how are you planning your overall model in a way that when you make a forecast, you combine together subsystem evolving in different time scale as well? I think it's kind of complex to do.
It is.
So I was curious, how are you planning to manage this challenge? Thank you.
And I would say it's not only the time horizon that is challenging, but also the changes here, they are happening at different levels in the system, from the micro to the meso and the macro level as well. So what we are trying to do is to have those elements considered in the way that we build the backbone. And the backbone will be roughly the same, independently on what is the specific problem or design problem that we are trying to model. But then when we bring the mechanisms, those will be the ones that are particularly relevant for that problem that we are trying to address. They will have specific time frames that we need to define in a unit of measure that will allow us to even see the rebound effects happening. Because depending on the measure that we choose, it might be such a subtle change that would not really be possible to see. And it's also important to see for how long are we doing the simulation models. Is that a week, a year, 10 years, 100 years? That is also an important consideration to take. But this, I would say, depends on the specific system that we are evaluating at a given time. Thank you.
Thank you. Thank you to all of you.
There was a final question there. She's been raising her hand
I don't know
all the way through, but we can talk later.
Very last? Okay. Where was it?
Do you want to ask it? Later? Good.
Okay, so thank you very much, Daniela. Thank you to all of you. We are now invited to get out of this big room just outside, and we are all invited for the welcome drink. So don't forget your voucher, okay? And enjoy the night and the Croatian specialties, and see you tomorrow.